So now we're going to be adding and subtracting rational expressions with unlike denominators. So we already pretty much know everything we need to know from the last section. So if you understood everything we did then, now we're just putting the pieces together. So here's the procedure to add or subtract rational expressions when the denominators are not the same. First, factor each denominator if you can, so that you can look at what the factors are that you're dealing with. Then, for each fraction, multiply the denominator by whatever additional factors are necessary so that the denominators are all the same, so that they have all the same factors as each other. While you do this, also multiply each numerator by the same factor you multiplied the denominator by. Then add or subtract the numerators and put the result all over that common denominator. And if you can simplify or reduce the result to lowest terms, go ahead and do that. So let's try some examples. X plus 5 over 9 plus x plus 2 over 6. First, we want to factor each denominator. Here the denominators are just numbers, but the number 9 can be broken up into 3 times 3, and the number 6 would be 2 times 3. Now look at what factors each denominator has. This one has a 3 and another 3, but it's missing a 2. And the second denominator has a 2 and a 3, but it's missing a second 3. If we want them to have all the same factors as each other, the first denominator needs to have a 2 to match up with the second one, and the second denominator needs to have another 3 so it can match up with the first one. So we're multiplying by 2 for the first fraction, and by 3 for the second fraction. And whatever we multiply by on the bottom, we have to multiply by the same thing on the top. So the first fraction, now we have 2 times x plus 5 over 2 times 9, which is 18. And the second fraction becomes 3 times x plus 2 over 3 times 6, which is 18. Now that they both have a denominator of 18, we just add the numerators, 2 times x plus 5 plus 3 times x plus 2. And that simplifies to 2x plus 10 plus 3x plus 6. And after you combine like terms, that's 5x plus 16 all over 18. There's nothing we can do to simplify that, nothing factors, there are no common factors to cancel, so that is the answer, 5x plus 16 over 18. Let's try another one. 2 over x plus 3 plus 6x plus 1 over 3x plus 9. Factor the denominators. Well, we can't really factor x plus 3, but the 3x plus 9, we can pull out a common factor of 3 and write it as 3 times x plus 3. Now, if we want these two denominators to be the same as each other, I can get that to happen if I just take that first denominator and multiply it by what? Well, what does this guy have that this guy doesn't have? 3. So I'm going to multiply by 3 on the bottom and on the top, and I don't have to do anything to this second denominator. It's already got everything it needs. So now we have 6 over 3 times x plus 3 plus, same thing we had before over here, 6x plus 1 over 3 times x plus 3. And when we put those together all over that common denominator, we have the 6 plus the 6x plus the 1. And I went ahead and added together the 6 and the 1 to get 7. So 6x plus 7 over our common denominator of 3 times x plus 3. You could leave it like that, or if you want, you could multiply that out and write it as 6x plus 7 over 3x plus 9. Another example, 10 over y minus 2 minus 2 over y plus 4. So this time we are subtracting these fractional expressions that have different denominators. First thing to do would normally be to factor the denominators. Here there's nothing to really factor. Each one just has that one factor. But if we want them to be the same, the missing factor here would be y plus 4, and the missing factor here would be y minus 2. So to get them to both have the same factors as each other, I'm going to take the first fraction and multiply by the missing y plus 4 on top and on the bottom. And take the second fraction and multiply it by the missing y minus 2. So now they both have the same denominator, y minus 2 and y plus 4 multiplied together. On this one we have 10 times y plus 4 on the top. And on this one we have 2 times y minus 2 on the top. So when we go ahead and subtract, the denominator will just be y minus 2 times y plus 4. Doesn't matter which order you write the factors in. And the numerator is going to have 10 times y plus 4 minus 2 times y minus 2. Or after we distribute and get rid of the parentheses, that would be a 10y plus 40 minus 2y, and then minus 2 times minus 2 would be plus 4. Now, combining like terms up here in the numerator gives me 10y minus 2y would be 8y, plus 40 plus 4 would be plus 44. So now we have 8y plus 44 over y minus 2 times y plus 4. Now you could just leave it like that. That would be one way of writing the answer. You could factor out a 4 on top, write it as 4 times 2y plus 11 over y minus 2 times y plus 4. Or you could multiply out the denominator. If you FOIL those together, you get y squared plus 2y minus 8 for the denominator. So all of these are kind of equally simple. They don't have any common factors in the numerator and the denominator that we could divide out. So we could leave the final answer in any one of these three forms. How about 11 plus 4 over y? The 11 doesn't really look like a fraction, doesn't really look like a rational expression, just looks like a whole number, but we could write it as 11 over 1. So the denominator here is 1, and the other denominator is y, and if we want the denominators to both be the same, we could take this 1 here and multiply it times y. So we're multiplying the first fraction by y on the bottom and on top, which turns it into 11y over y. The second fraction is fine the way it is, 4 over y. So now they both have the same denominator, and we just add the numerators, 11y plus 4, all over that denominator of y. There's nothing we can really do to simplify this, so that's our answer, 11y plus 4 all over y. How about 9 over x plus 4 over 5x squared? We need to get the denominators the same by taking what they already are and multiplying by something else. So the first denominator is just an x. Is there something we could multiply that by so that it would match the second denominator? Well, it's missing a 5. It has one factor of x, but it needs another one. X squared would be x times another x. So let's multiply the x we already have by 5x. That would turn it into 5x squared, and then that denominator would be the same as this other denominator. Okay, the second fraction, we don't have to do anything with it. It's already got 5x squared as its denominator. So now we get 9 times 5x is 45x over x times 5x is 5x squared, plus 4 over 5x squared. They have the same denominator. We just have to add the numerators. 45x plus 4 all over 5x squared. 1 over x minus 1 times x plus 3 minus 1 over x plus 3 squared. And here the denominators are already factored for us. We don't have to do any factoring because we can already see what the factors are. This one has an x minus 1 times an x plus 3. And this one has an x plus 3 squared, which means an x plus 3 times another x plus 3. So if we want them to have all the same factors as each other, what's missing from this first denominator? And then we'll look at what's missing from the second denominator. But the first denominator, what's missing here that we would have to multiply on to have the same factors that we have over here? That would be a second factor of x plus 3. We have one of those, but we need another one to match what we have going on over here. And then what's missing from the second denominator? The x minus 1. So I'm going to multiply the first denominator by another factor of x plus 3, so that then we'd have x plus 3 squared. And I'm going to multiply the second denominator by x minus 1. And whatever I multiply in the denominator, got to multiply the same thing in the numerator. So when I do that, now both denominators will have an x minus 1 times an x plus 3 times another x plus 3. They will be the same, all the same factors, same denominator for both fractions. So now we have 1 times x plus 3 over all of those factors, minus 1 times x minus 1 over all of those factors. Since they have the same factors in the denominator, we can put them all together over that common denominator, x minus 1 times x plus 3 squared. And in the numerator, well, if you multiply things out, 1x plus 1 times 3 is 3, minus 1 times x, so minus x, and then minus 1 times minus 1 would be plus 1 here. So x plus 3 minus x plus 1. Careful, it's minus a minus, so that's plus. And what does this simplify to? When you simplify this numerator by combining like terms, you just get 4. X minus x cancels, and then 3 plus 1 is 4. So our final answer is 4 over x minus 1 times x plus 3 squared. 4 over y squared plus 10y plus 9 minus 7 over y plus 9. Factor the denominators. Let's see, y squared plus 10y plus 9 can be factored into y plus 9 times y plus 1. Stop and check that if you don't see that. The y plus 9 can't be factored, but it's already one of the factors we have over here. It's missing the other factor, y plus 1, so that is what we would need to multiply by over here to get this denominator to match the other denominator. So I'm going to multiply by y plus 1 on top and on the bottom of this second fraction. Now they both have the same denominator as each other, so we have 4 over y plus 9 times y plus 1 minus 7 times y plus 1 over y plus 9 times y plus 1. So that's a 4 minus 7y minus 7 times 1. So 4 minus 7y minus 7 all over that common denominator. And combining like terms in the numerator gives me a minus 7y minus 3 over y plus 9 times y plus 1. So there's my final answer for that. Don't see any way to simplify it. It's in lowest terms. That's the answer.